Hello, welcome to the physics video tutorials. This is kinematics session 3, 4 and 5. In this session, we are going to talk about acceleration and explanations of equations of motion. So first, let us define acceleration. So, acceleration is basically the rate of change of velocity of the body. And since velocity is a vector quantity that we already know, so acceleration is also a vector quantity. Alright? And its unit of measurement is meter per second square. That means in case of SI system, velocity is meter per second. So acceleration is change in velocity per second, means meter per second, that is basically meter per second square. So as I said, velocity is a vector quantity. So it is described in terms of two things. The one is magnitude and the other is the direction. Alright? Because velocity is a vector quantity, so all vector quantities are described in terms of two things. One is the magnitude and the other is the direction. So it can be changed by changing magnitude or direction or both. So how can we change the velocity? We can change the velocity by changing its magnitude, by changing the direction of motion, or we can change both of these things. Suppose a particle is said to be moving in a curved path. For example, one object is starting from the point A and reaching the point B, and it follows a curved path like that. Suppose a particle is said to be moving in a curved path, then can you say that it has a non-zero acceleration? Think about it. Can you say that it has a non-zero acceleration? If you say yes, then of course you are right, because curved path means direction of velocity is variable. Velocity is always taken to be along the tangent to the path. So at this point, velocity must be in this direction, and when the particle is crossing this point, then its velocity must be in this direction. So curved path means direction of velocity is variable, hence velocity is changing, even if the body maintains constant speed. Alright? Just for this fact that particle is moving in a curved path, then it is for sure that its acceleration is non-zero, because at least the direction of the velocity is changing for sure. Alright? And in this case, speed may remain constant, that is not the point, and it may also change. And suppose one object moves along a straight line. If I say that one object is there and it is moving in a straight line from some point to the other, then we require further information regarding the speed of the body. If the particle is moving in a straight line, then we know that its direction of motion is not changing. That means its motion can be acceleratory, means it can have a non-zero acceleration or even zero acceleration. So for deciding this fact, we require further information about the speed of the body to decide whether it is accelerating or not. Because if speed is constant, then it must be a case of zero acceleration, but in a straight line, there is a possibility of change in magnitude of the velocity, so it will be a acceleratory motion. But in a curved path, it is for sure that it is acceleratory motion, means acceleration is non-zero in this case. But in a straight line, we need information regarding speed also. Alright, as in case of velocity, we can find average acceleration for a given time interval or instantaneous acceleration at a certain instant of time. For example, one object is moving with a velocity say v1, and in delta t time interval, its velocity changes to v2. Then v2 minus v1 is the change in velocity divided by the total time. So it will be the average acceleration for that interval. Alright? For a particular interval, if we are given with the initial velocity and after some time the final velocity, then we can find the average acceleration by calculating v2 minus v1 divided by delta t. Here this thing is very important, that v1 and v2 need not be in the same direction, and v2 minus v1 need not be either in the direction of v1 or v2, because in general what happens that suppose velocity v1 is this way and velocity v2 is this way. Then how to calculate the v2 minus v1? If it is v1 and it is v2, then it will be minus v1. Alright? If we add minus v1 with v2 vector, then we'll get what? change in velocity v2 minus v1. So by completing this parallelogram, we can find the sum of v2 and minus v1, which will be equal to the change in velocity. So you can see here that this change in velocity, which is delta v, is neither along v2 nor along v1, because change in velocity can be in any direction. Alright, so that is what it is written here. And other way around, the instantaneous acceleration A is equal to dv by dt, and here v is the instantaneous velocity. So for calculating the instantaneous acceleration, we need velocity of the particle as a function of time, and by differentiating that relation, we can find the instantaneous acceleration. One more important point here can be noted down, that direction of acceleration has nothing to do with the direction of velocity. Acceleration only tells about direction and magnitude of change in velocity. And we know that here I have already explained to you that change in velocity can be directed anywhere irrespective of direction of velocity. In dynamics, we will learn that force generates acceleration along its direction. As we know, the equation F is equal to ma. This much Newton's laws of motion all of you must be aware of, although it is next chapter in our physics. So F is equal to ma means force generates the acceleration along its direction. And suppose one object is moving with some velocity in a direction, and then force can be applied in any direction, and based on it velocity will change, and the final velocity in general may be different in direction than that of acceleration, and as well as the initial velocity before the acceleration was applied. If suppose some object is moving in this direction, alright, the velocity direction is this, at a particular instant, then we apply some acceleration by applying a force. So force can be applied in any direction. You can apply force in this direction, or you can apply force in that direction or that direction, because velocity has nothing to do with this. So force can be in any direction, and according to the force, the change in velocity will be decided due to the acceleration, and so the final velocity will be decided based on the initial velocity and the change in velocity, which is because of this acceleration. So just by knowing the acceleration, we cannot decide the direction of velocity unless we are told about the initial velocity of the particle, because from the acceleration we can predict only the change in velocity. And one more example, suppose one object is moving along a straight line with some constant velocity, and here one point you should be very clear about, that if I am saying that constant speed, so constant speed means just magnitude of the velocity is constant, but its direction of motion can be changing. But when we say constant velocity, since velocity is a vector quantity, so constant velocity means magnitude of the velocity as well as direction. Both are fixed. So it must be a case of zero acceleration if continuous. So for example, suppose one particle is moving in a straight line with some constant velocity, and then we decide about applying some acceleration. So if suppose acceleration is applied on the object along the same straight line on which the particle is moving. If the particle is moving in a straight line, and suppose acceleration is also applied along the same line, then object keeps on moving on the same line. Magnitude of velocity may increase if acceleration is along the velocity, and magnitude may decrease if acceleration is opposite to velocity. So one thing for sure is that if we want a particle to follow a curved path, then acceleration must be acting in a direction different from that of velocity. Are you getting my point? One object is supposedly moving in a straight line, and then some acceleration is applied on it. And if suppose acceleration is applied along the same line, in that case the particle will keep moving in the same straight line. Its velocity magnitude may increase or decrease depending on the direction of acceleration, whether it is parallel to the velocity or anti-parallel to the velocity. Otherwise, the particle will not leave that particular line of motion. So if you want any particle to move in a curved path, in that case, direction of acceleration must be different from the direction of velocity. Only then the particle can follow a straight line path. Alright. So, particle moving along a straight line, the direction of acceleration is either in the direction of motion or opposite to the direction of motion. Suppose here it is the case that car is moving in this direction, and acceleration is applied opposite to this direction, then its velocity must be decreasing. And in this case, velocity is in this direction and acceleration is also along the same direction, then it is a case of speeding up. Normally, there are two terms which are used. One is accelerating motion and the other term is retarding motion. So how do we decide whether it is accelerating? Accelerating motion means magnitude of velocity, of course, is increasing, and retarding means it's decreasing. So when it happens, whenever the direction of acceleration is opposite to the velocity, in that case, the motion will be retarding. And if they are along the same line, then the motion is accelerating. It has nothing to do with the sign what we apply on A. Suppose for these cars, let this particular direction is the positive direction. Then for first case, we know that velocity is positive and acceleration will be negative. And it is a case of retardation. Alright. Here you can see that velocity is positive and acceleration is also positive. And it is a case of acceleration, means speeding up. And suppose if we think that this particular direction is positive, that we can always assume, then in that case velocity is negative and A is positive. And here velocity becomes negative, A becomes negative. So you can see it here. In this case, acceleration A is given a positive sign. But in spite of that fact, this is a case of retardation because velocity and acceleration has got opposite sign. So don't think that retardation in case of retarding motion will always apply a negative sign for the acceleration. No, that is not the case. Retarding merely means velocity and acceleration are opposite, right? So if velocity is taken to be positive, then A will be negative, and direction of velocity is negative. In that case, A will be positive for the retarding motion. So positive, negative, just by knowing the sign of plus minus for acceleration, we cannot say that it is a case of acceleration or retardation. It is always in conjunction with the sign of the velocity. Whenever these two quantities have got opposite sign, then it will be a retardation. And if they have got the same sign, then it is acceleration. Here you can see that A is negative, but in spite of this fact, here the motion is accelerating because velocity is also negative. So these are some of the introductory things that we discussed about the accelerating motion. So now we will come to the part where we will be deriving our three equations of motion. As you are already aware of that, V is equal to U plus AT, S equal to UT plus half AT square, and the third equation is V square equal to U square plus 2AS. And in all these three equations, we have assumed acceleration to be uniform, means constant. Uniform acceleration. What is the uniform acceleration? When acceleration remains constant in terms of magnitude as well as direction. In case of non-uniform acceleration, then we cannot use these three equations. So the next thing, we'll first derive these three equations and then proceed with the kinematics problems.